these notes, and then tomorrow we probably have to hit the homework. Sorry. Do it. I know, and I'm giving you extra credit already. All right. We're going to develop an understanding of piecewise functions. You want to know what a piecewise function is? It's just a whole bunch of graphs on the same grid, and it makes it a function because the graphs start and stop. Sound okay so far?
Yeah.
What?
I don't have the notes.
Oh.
Me neither.
Oh, they're on the floor. Olivia totally threw them on the floor.
Why do I have two
What?
Why do I have two
Turn it away like it, dork.
But I should get three for doing it all.
No.
Oh.
Alright.
That's some fake.
I know. Alright, so a model airplane taxis, so it drives around for 3 minutes. Then it ascends, so it takes off and it's in the flight for 5 minutes. And then it reaches a height of 100 feet. And then maintains that height for 8 minutes. Finally, it descends at a slower rate than before. Reaches the ground after an additional 10 minutes. So what does this kind of thing look like? It looks like this.
Wow.
It looks like that. Okay? So you have a steeper as it ascends because it took off, it ascended faster than it descended. What is this region right here about? What happened here? Yeah, it's when it's on the ground, a taxi. And we're using the y-axis as its vertical feet and the x-axis as some sort of time. Those extras, you just go recycle, and there's a recycle bin back there. Thank you. All right, so you have 4 quadrants, x, y. Quadrants are labeled 1, 2, 3, 4. They go counterclockwise, and we'll talk more about that later. So a piecewise function is a function represented, I know this is on your thing, so if you want to jot these notes down, you totally can. The function represented by a combination of equations, each corresponding to part of the domain. So we did give you this function where you have the function at x. This is just like saying, hey, you have f at x equals 2x minus 1 and also f at x equals 3x plus 1. It's just we're combining them together. The x is less than or equal to 4 and x is greater than 4 is the restricted domain. And you're going to see how that goes. And then, because remember, a function, if you draw a vertical line, it can only cross that graph once. So that's why it's a piecewise function. If I drew both of these lines entirely and they crisscross each other, if you draw any vertical lines outside where they crisscross, it intersects twice. So that's why we have a restricted domain. Does this make sense so far? Everybody happy? And I know some of you are jotting stuff down, so I'll give you a moment. I'm so glad we were safe out there with that fire.
I was really enjoying that shade.
Have you ever been in a real fire?
Oh, I've started fires. Heck yeah.
Honestly, like, I could expect that.
Yeah, but I can't tell you where and when and who I was with because statute of limitations hasn't run out yet.
It's jolly.
Oh, yeah. Started fires, stole cars, deal drugs.
Wow.
That's poker.
Oh,
We
yes, right.
already
You
did
got vomited
all
since
that
7 a.m. this morning. What's that, old one?
Yeah,
I am. I am he. All right. Hey, can I move off this screen, or is anyone still writing down?
Continue.
Oh, well, thank you.
You're welcome.
All right, so 3 skills with piecewise. You're going to evaluate it, you're going to graph it, and then you're going to write the equations for a piecewise function. So you're generating the equation. When you generate an equation, you need to realize you have restrictions on the domain. And I think I have an okay way of showing you how the domain thing works. Sound okay so far?
Yes.
You have these written down, or do you need them written down, or are they on your slide? Oh, good. All right, so this is 2 piecewise functions. So what you're going to do is if we're going to evaluate this first one, we want x equals 0. So where does x equals 0 live as far as our domain? Does it live on the top equation or the bottom equation? Top. Why the top? Because 0 is less than 2. So I will use that top equation, so I'll get 0 plus 2, so I get 2. All right, what about this one? Where does this live, on the top or the bottom equation? Bottom, because the bottom is 2 is greater than or equal to 2. So I'm going to take that 2 and plug it into the bottom, so I get 2 times 2 plus 1, so I get 4, that's going to give me 5. Make sense? And where do you think this one's going to live? Top or bottom? Bottom, because 4 is definitely greater than 2, so we're going to use the bottom equation. Just plug it in and get a value out. So 8, 9. There we go. Making sense?
Yeah.
Everyone happy? Do I have to cover any? Is there any more on that slide I need to worry about? All right, can I move on? Okay, let's try these. Shout out. Top or bottom? Top or bottom? Top. Okay, if you plug it in, 2/3 of 6 is 4. 4 plus 2 is 6.
Bottom.
This one's a bottom. That one's a
Bottom.
top because x
No.
is negative 6 is less than. So I'm plug it up on top, so I get plug negative 6 in. 2/3 of negative 6 is negative 4. Negative 4 plus 2 is negative 2.
But it's negative x, so wouldn't it be negative x? It's like 6 would be 2 negatives is a positive.
So look at this right here. This refers to this. So I want values that are less than or equal to 6. So negative 6 is that way of it. We use the top one on this one because we had it equals. This is negative 6 is less than that. But this one is going to go to the bottom because 12 is greater than 6.
Plug it into the equation.
I did. Oh, I just take this and I plug it in right here. And I take this and I plug it in right here. And then I'm going to take this and I'm going to plug it in right there. So then I get negative 12 plus 3 is negative 9. Making sense? Pretty easy. Any other slides there I have to worry about? All right. So now we're going to graph these. Now, guys and girls, this is where I think if you have like an extra color of highlighter or whatever in your bag, that would be the good thing. So you see these two? That's going to be our restrictions. So I think it's best if you do this. Hey, I want to do, being I'm using the exact same number, I'm going to say that is where my lines are going to stop and or start. Okay? All right, so I'm going to do this one in red. So that one has a y-intercept of 2. It has a slope of up 1, right 1. Now, this is just less than. So if I go up 1, right 1 right here, this right here has to be an open dot. And this is what that graph looks like. Does that make sense? Why is it an open dot right there? Because I don't have this equal. So what do you think this region will have? Closed dot. And so that'll allow when you do the vertical line test through here, even though it appears that the graph goes up to this point, you don't include there, but you include something else. Okay, so let's do this one in blue. Okay, so I have a y-intercept of 1, and then I'm going to go up to right, up to right 1, up to right 1, up to right 1, up to right 1. Okay, so I use these just as a guide to get up there so I can start graphing here. This graph doesn't exist going this way. This red graph doesn't exist this way. If they did exist, it wouldn't be a function because the vertical line test wouldn't pass. That make sense?
Yeah.
So do you understand what I did with the yellow highlighted line? Does that make sense? And again, you got the highlighters, you're going to nail it. So is that yellow line really in existence on our graph?
No.
No, it's just we're using it as a guide. Can I move forward?
Uh-huh.
All right.
Are we turning in 480?
We might do it tomorrow. All right. Do I have the same type of restriction?
Yeah.
Yeah. So this, again, is there. Okay. And again, that yellow line doesn't exist on the graph. It just becomes a really nice guide for us when graphing. Oh, shoot. I have a y-intercept of 2/3. Bless you. So 2/3. So that's about 2/3. I know it's a little off. I'm sorry. So 2/3. So I'm going to go from that. I'm going to go up 2. So ready? 1, 2, and then right 1, 2, 3. So up 2.
Starting out.
All right, does that make sense how I just drew that line? So I found I had a y-intercept of 2/3. Gypsy, turn around. Don't act like you're victimized. You wouldn't have gotten hit by the face by something if you were turned around correctly.
He's blocking the board. I have a perfect view until
I know.
he stares at me. Gypsy.
I don't know. Cupcake, just settle down, all right?
Now you're sunshine.
All right. This line, we have a y-intercept of +1 right there. Agree? I'm going to go down 1, right 1. Down 1, right 1. So here's my solid dot here. And that line goes that way. Why is it a solid dot on the red? Because we have the equal sign. And those are where we know to graph. Okay? The greater than 2 tells you you're going to graph to the right of it. The less than or equal to you graph to the left of the yellow line. Make sense? Moving on. All right, so now we have three different equations. So I'm going to have this one with this highlighter. There's one line. Okay, next line I'll do in green. Okay, it goes between 0 and 2. Okay, we know it's going to be between the yellow and the green, something's going to take place. And then this last one we'll do in blue. So we want greater than 2. So we don't really have to do that. I mean, we could do a little thinner saying, hey, this does exist in here. Of course, you can't see it because the color scheme's goofy. Okay, I don't really like that dark line in there because, is that another axis? No. All right, so those are all of our separations. This, the blue one, we're not gonna use at this point. It's gonna be the same as the green. Okay, so we'll say that that's supposed to be a green color. All right, first equation, this one, x plus 3. Y-intercept up to 3. Open dot. I go up 1, right 1. But I want values that are less, so it's actually going this way. Open dot on that because we don't include it. What does the line f at x equals 3 look like? It's a straight line, but what kind of straight line? So horizontal at 3. So it's going to be a solid dot and a solid dot and then horizontal. Okay, it's solid dots on both because we have the equal sign that we're using. And then the last line is negative x. So I have a y-intercept here, so I go down 1, right 1, down 1, right 1, open dot, down 1, right 1. And again, that's my piecewise function. The red, the blue, and the black lines are part of my piecewise function. It is a function if I draw a vertical line. The blue and the red do seem to share a point, but the red has an open dot on it. The black and the blue appear to share a point, but you have a solid dot on the blue line, not on the black line. Question, yeah?
You probably said this before, but how do we know which way we need to, like, go? Yeah, draw the.
So I'm still using the y-intercept like y equals mx plus b. So like on this one, I would have went up to 3, and then I went up 1, right 1. But I realized I was going the wrong way. So technically, this line is going to keep going this way. Okay? That's how you would graph it normally. You plot this point right here, and you go up 1, right 1, up 1, right 1. But we have to go down and left because we want values to the left of the yellow line, less than 0.
Oh.
Okay? Make sense?
Yeah.
All right. Moving on. All right, so now this is a step function. Okay? And where you find these step functions is like post office examples all the time. Okay? I know it's dumb because you're like, I haven't been to the post office. You know, I have a mailbox out front, and I don't know who puts stuff in there, but there's stuff in there every day. Well, it's a little buggy thing that drives around. So this is called the step function. So what do you notice about this function? It looks like steps. If I draw any vertical lines in here, they all will show that it's a function because it'll only touch it once. So this is a step function. Do you notice how you have a solid dot at one end and an open dot at the other? Solid dot, open. So if I draw my vertical lines, we don't interfere with it. Okay? This is a piecewise function. This is a bunch of horizontal lines where we're bound by each horizontal line. Is that okay to say that? I can't sit on the desk with my phone in there. I'm sorry. Why is my phone not in the back? Well, we were interrupted by a fire alarm. All right. Can I move on?
I guess.
All right, so a piecewise function, so a step function is a piecewise function whose graph resembles a set of stair steps. Okay, so y equals 0, y equals 10, y equals 16 are horizontal lines going through 0, going through 10, going through 16, and then we have it bounded. The real life situation, again, is with the post office. If you have a 49-cent stamp on your envelope can weigh between this and this. If your envelope weighs more, then you have a new rate that you're going to pay at. But that new rate could be at that weight up to another weight. Okay? So just to make it easy, let's say the post office said from 0 to 1 ounce, 49 cents. From 1 or greater than 1 ounce, but less than 3 ounces, you pay 55 cents. Something like that. Okay? So it's just based on how large your packaging is, how much it weighs, is how they will charge you for it. The other companies, FedEx and the other guys that also deliver some sort of parcels have the same type of idea. How does Amazon get away with charging you $100 a year and you get those Amazon Prime, which they have some crappy movies that are, it's like,
Amazon Prime is so bad.
What?
the movies are, yeah, but I love the fact that I can order something before I even hit send. The guy's at my door with it. It's like, dude,
That's just lazy.
I know. So,
I think the FedEx people are good at that.
Why are you relying on Amazon Prime for your movies?
Because sometimes I just finish everything on Netflix.
yeah.
All
right. Other places that you might see step functions would be, you ever go to those, where they have like all the colors of M&Ms where it's like, oh, we have all red M&Ms, all blue, all green. And you think that it's some magical experience because you're like, look, I got red at the bottom, blue at the middle, and yellow at the top. Those are, you've never seen these? Or those straws you fill up, the powder. And you got kids that are inhaling powder and they act like it's a Tide Pod challenge, but it's candy instead.
Yeah, exactly. I know what
You guys just didn't have a chance with this Tide Pod challenge. I mean, you look at those things, it looks like candy.
Yeah.
It looks like something that would feel good putting in my mouth. And Tide's like, oh yeah, that's what our detergent's supposed to do. It's like, put another dye in there, make it like vomit color. And people are like, dude, that doesn't look good. Are we good? Can I move on?
Yeah.
Here we go. All right. So taking a look at this piecewise, first thing I want to do is I just want to identify, come on, yellow. Bless you. What's that line right there? What's that line going to be? Is it a restriction? Okay. So it is 2. So I'm going to have one equation that is less than 2. And I'm going to have one equation that's greater than 2. Now I'm going to erase that because we can't really see the dot. So which equation do you want, in this case, do you want that dot to be a part of? Top or the bottom?
Bottom.
Bottom? You got it. So we had to choose. We made it with the bottom. We're going to make that equal. Okay? All right. Ready?
Ready.
I'm going to take this one. This is the x is less than 2 equation. So I do function at x. I make my fancy looking bracket. Still with me?
Yeah.
So now I want to find the equation to this line right here. This one right here. Okay, so it appears it crosses my y-intercept at 4. Agree? And it's a positive 4. What does it appear the slope is? Up 1, right?
2.
2? So I have a slope of 1/2. There's my first equation. My second equation is right here. Okay? So the second equation, you can be like, okay, well, it looks like I gotta go down 2, right 2. I'm gonna go up 2, right 2. So it looks like it would intersect right there. Do you agree?
Yeah.
So what's my B value of my purple? 7. We're using it as a guide, doesn't graph all the way over to it. And then we have a slope that's down 2, right 2, or down 1, right 1. So I have a slope that is negative x. So here's my equation. And again, we had to determine, did we want, because these were connected like that at a point, I need to pick either the top restriction or the bottom restriction as the domain to include it.
Either way.
Yes. Moving on? All right.
Yeah, no time.
We're okay. All right. I have a restriction at -2. Okay, so the top one will be the one on the left. It looks like I'm going to go less than -2. The top one I'm going to go greater than or equal to -2. Why did I choose? So this one here will be our -2. So if I keep on this graph, down one, right one, down one, right one. I think I'm off. It goes down two, right one, down two, right. Actually, it hits right here. So I have a y-intercept of -8. Down one, right one is a -x. So there's my first equation. Of course, I have f of x is equal to this. And then the top one. It looks like I have a y-intercept of 1. Agree? And then I go down one, down one, right 2. So it's got a slope of -12x. And that's our equation. All right, so I know I'm out of time. So 4e was what I had told you was due today, right?
Yeah.
Bring that tomorrow. Still with me? And I want you to try 4f. Try it. Try it. Try it. Have a great day, everyone. Take care of one another.
Thank you.
You're welcome, everybody.